Good morning, everyone. Okay, I will start just in a minute. There are two people right now. Let's wait for some more time and so that other people also join in.
Hello, Sonatan. Good morning.
Good morning. Okay, the Gooey people are not here yet. Okay, so in that case, you need to unmute yourself and speak up if anyone wants to talk to them. Okay. All right, let's start then. We'll be implementing all the algorithms that we have seen in the last 2 days, in the last two sessions.
And Sanatan, tomorrow is the holiday, right?
I have no clue. Has it been
Because
communicated to you?
we have got a email, so that's what I wanted to inform you that.
Okay, all right.
Yeah,
Thank you. I didn't know
yeah.
about this.
Because you are not getting the emails frequently, right? So
No,
that's what I just thought
uh,
of informing you.
unless, thank you. Unless, uh, I don't know, they have been procrastinating, or maybe they keep you in the loop, but instructor, who cares? All right. So
Simply
let's,
cooperating.
no, they are cooperative. This is not that. I believe they just forget.
Okay, okay, okay. Get it.
They forget the most important person who's going to teach. That's okay though.
True. Okay.
I have to ask them early morning every time. Sometimes for the links also. So if the session is at 9 o'clock, I'll be asking them at 7:30. Please give me the links at least. Okay.
Mhm.
Anyway, that's fine. Okay. So we'll take a classification data set. Do you want me to create one on my own, or shall I take an existing one? What would you recommend?
Existing one means that salary thing you're saying.
No. A new data set. We are talking about classification today.
Okay, we'll take a new.
Okay, let's take a new one then. Okay. So I'll start with something which is binary, and then we will move on to multi-class. Okay, so this is a binary data set. So the objective is to predict if someone has cancer or not. Let's import this data set. The syntax remains the same for importing any data set from this sklearn.datasets. So you can say that, okay, create an object of your data set, and then you can get the features from this property called as data. So these will be your features. The size will be number of samples times the number of features. Okay, and output would be, I'm storing it in Y, and the property is called as target. And the size of this output would be your number of samples times nothing. Okay, so basically this would be this. Okay, I'll just mention it. We are starting with binary classification. All right, so let us see how many samples are there. So first, let us see the description of this data. Okay, what is it that we intend to achieve? So the objective is we have 569 samples, a total of 30 features. And these are the features, okay? Radius, texture, perimeter, area, smoothness, compactness, concavity, so on, okay? And you already, so these are, I believe, the 10 features. for every feature you have mean, standard error, and worst. Okay. So for every feature you have 3 values, basically a total of 30 values you are given. So 10 into 3, you can imagine it like this. Okay. So for radius, you will have the mean radius, the field radius, and there is something called as worst radius. Okay. So these, for every feature radius, you have 3 values. Similarly, for texture, you have 3 values. Parameter, you have 3 values. Okay, those are your features. And this is what is shown to you, the minimum and maximum value for all the features. You can see that the ranges are very, very different. So we need to either normalize or standardize. We will talk about what to do. Okay, and let's see what the output is. Output is probably this. Okay. So we have to predict if someone is suffering from cancer or not. So these are the 2 classes. So it's a binary classification task. These are the 2 classes. Now there is a difference here. Okay. Typically, let's say if somebody has cancer, what label do we assign?
1.
1, right?
1.
In this case, it is, label 0. Okay. The very first label is 0. So malignant actually means people having cancer. Okay. And benign means healthy people are not having cancer. So this is class 1.
Class 1.
So, yeah. So just keep this in mind. So that when you are checking, say, precision or for recall, you do it for class 0, not for class 1. Okay. I don't know why they made it like this. Okay. But this is the case. All right. So let's see how many samples are there with people having cancer and people who are actually healthy. So maybe I can, so there are several ways to check it. You can import, I've already imported NumPy. So you can say NumPy unique. The actual values are in Y. So just to show you, okay, these are your Y values. These are your Y values. Okay. So you can see there are a lot of zeros and ones. Okay. So if you want to see how many zeros and ones are there, you can, so if you just say unique, it tells you how unique values. And if you type return counts, it gives you the frequency for every unique value. So you can see that 0 is 212 and 1 is 357. And that also makes sense, right? Cancer people would be less. Yes or no?
Yes.
That also makes sense, right? Okay. Now, have we done logistic regression before? As in, I just want to confirm this. Does anyone remember? Have we implemented logistic regression before?
No.
We haven't, right? Okay. So what I'm going to do is I'm going to start with, say, 2 features so that we can visualize what is happening. And then we will move on to this data set with all the features. Okay. So you guys tell me. So these are your features, by the way. Okay. These are your features. 30 features you have. Which features do you want me to pick? I just need 2 features. Okay. Which features do you want me to pick?
Mean perimeter and mean area will pick.
Okay. Let's say these 2. So
Yeah.
this is at index 2 and 3, right?
Yeah.
Okay. So I'm going to pick these 2 features. So my data is in X. Okay. So I'm picking all the rows. This means pick all the rows. And I want column number 2 and column number 3. This is what we want, right?
Yes, Sanatan.
Okay. So this is the data that you have. If you look at this data, this is 569 times 2. So 2 features. Okay.
Yes.
Okay. So this is the data that I'll pick. So let's call this as my input. Okay. Now what we are going to do, we are going to plot this just to visualize what is happening.
Yeah.
Before that, let me split it into train and test. Okay. And then we will do, say, k-fold cross validation if needed. Okay. So go to model selection, split it into train and test. Call this function train test split on your data. So data is in X and Y. Your data is in input rather, INP. You specify the size of the test set, maybe say 30%. And the random state to ensure that we get the same outputs. Okay. Now, I need to specify one more argument here. we will discuss about this. So we will get train features, test features, train outputs, and test outputs. Okay. Now, okay, we have a total of 569 samples, right, in the data set, in the original data set. And this is the ratio of class 0 and class 1. So if somebody asks me, what is the probability score? Okay, just look at this. Okay. So if somebody asks me, what is the probability score, okay, of class 0 and class 1, okay, what would you do it for, say, class 0? What would you say? What is the probability?
Sum of these two.
Sum of these two, right? So I'm going to show that what that value comes out to be. I'm going to divide it by the sum of this. Okay. Okay, so these are the probability scores for class 0 and class 1. My question is this: when you split your data using train and test, okay, this function train test split, is it guaranteed that in the train set you will see this ratio?
No,
And the test set also, is it guaranteed? No, right?
no.
Okay. If you want to guarantee that, okay, this is what should happen, don't you think that would give us a better idea of how the model is performing?
Yes.
Does that make sense? I mean, when you are going to split your data, you have to ensure that the labels also are split in that particular way, right? The original distribution of the label should be followed. So this is one thing that we will do. There is this argument called as stratify. And you can assign this stratify, this output y. So whatever is the distribution in y, that will be followed to split your data. Okay. So I'll show you almost the same. Yes, go on.
Can you go again with that stratify once again?
Yeah, okay. See, do you see this, that this is the probability for class 0 and this is the probability for class 1?
Okay.
Okay, can I say that 37.25% of the samples out of 569 are for class 0 and 62.74 are for class 1? Does that make sense?
Yes.
Okay, now we are going to split this data into two halves, right? Train and test.
Yes.
So is it guaranteed that in the train set, the distribution of class 0 and class 1 would be exactly this?
We can't. What
And
is
you're
it?
doing it randomly, right?
Yeah, yeah.
Okay, you are doing it with some random state. Is it guaranteed that, let's say, in the 70% of the data, in the 70% of the 569 samples that you pick, 37% of the samples will be belonging to class 0 and 62% will be belonging to class 1. Is it guaranteed? If you just split it randomly.
Yeah.
It's not guaranteed. How can it be guaranteed? I give you 100 samples. Okay, let's say 30% samples are belonging to. Okay, let's see this. Okay, simple example. There are 100 samples. Okay, let's say that. Okay, I'll give you an even simpler example. Let's say 50 belong to class 0 and 50 belong to class 1. Okay.
Okay.
My question is this. Okay, when you split it into say 70-30, is it guaranteed that okay, when you split it into this say 70-30, so 70 for training, okay, and say 30 for testing. Is it guaranteed that 35 samples here will be from class 0 and 35 will be from class 1?
No, we can't say that.
No, right? I mean, it's not guaranteed, right?
Yeah, yeah.
However, don't you think we would want that so that when we evaluate our model, see,
We
when
need it.
somebody collects a data set, they are collecting it from a community, and that is a distribution that they observe. So when they are going to apply the model on new samples, hopefully the same distribution would be observed, right?
Yes.
Okay, so if you want to ensure that, provide this argument stratify y. Okay, I'm going to show you that this happens. Okay, the distribution would be very, very close. Okay, it will be very, very close to the actual number. It depends on, it depends on whether you have odd number of samples or even number of samples as well. So it might slightly deviate, but it would be very, very close. Okay, let's see. I'm going to show you in Y-train what is the distribution. Okay, so I'll just do this for Y-train. I'll show you for Y-train and Y-test both. Okay. So let me just print this first. Okay, look at this. And then I'll do it for Y-train and do you see that? Okay, almost the same distribution. See, because if there are odd or even number of samples, then it can deviate slightly. Okay. Similarly, I show you for test. It depends on how many samples you have originally. Okay. But it would be exactly the same. It depends on how many samples you are splitting. Okay. Can you split odd number of samples into two parts?
No.
No, right? So one or two samples might be here and there. If it is exactly even number of samples, right, then there would be no problem. You will get the same data set.
Okay.
I mean, you'll get the same distribution. But if there are odd samples for one class, then one of the partitions will get one more sample, right?
True.
Right. So that way the distribution slightly differs. Okay. All right. Okay. So this is what stratification does. This concept is called as stratification. Ensuring that stratification. Ensuring that you get the same label distribution. Ensuring the same label distribution in the train and test. Okay. In your splits, you can say, okay, in your split. Okay, or across your splits. Okay, that would be easier to across your splits. All right. By the way, there is a stratified k-fold as well. So we will use stratified k-fold instead of normal k-fold. Okay. All right. The data has been split. Even though I'm using two features, do you think it makes sense to normalize or standardize? You have seen the minimum maximum values,
Yeah.
right? So we should do that, right?
That was random actually, so we have to normalize.
So it was different, right? Diverse ranges.
Yeah.
So we will be, since we are going to use logistic regression, from my experience, you should standardize. Okay.
Okay.
You can normalize as well and compare the results. Okay. So I'm going to, for now, use standardize. Okay. This is just from my experience, I'm saying, but you can do either one of them. So let's go to pre-processing. Import your standard scalar. Standard scalar. For any linear model, you should standardize your data. Okay. Then you fit to your train data to get the mean and standard deviation of all the features, and then you transform. So this will give you your standardized data. Let's call it standardized X-train. Using the same scalar, you will standardize test set as well. So we have standardized our test data also. Now that the data is ready, let's call our logistic regression function. So logistic regression is present in linear model. So we'll call this logistic regression function. Okay, I'm going to fit my model onto this. Okay, so my data is in standardized X-train, outputs are in Y-train. So please remember the fit function is called on input comma output pairs. Okay, the fit function is called on this. So once the model is fit, okay, we can actually make predictions. So before I make predictions, let me show you what are the coefficients. So let's talk about intercept first. How many intercepts would be there? How many intercepts would be there? Okay, let me show you the data and then we can discuss. Okay, so I'm going to plot the data. Let's see. So your data is in X-train, the first column, second column. Okay, this is your data. Okay, that's how the data looks like currently. Now, I'll just give the labels also. Do you remember what was the first parameter name that you said? It was mean parameter.
Mean
and
parameter.
the other one is mean area.
Yes.
Yeah. And let's say PLT dot title. We are doing binary classification. I mean, currently, can you see that I don't have any colors indicating class labels?
Yes.
Okay, so I'm going to give colors also. So depending on what are the values in Y-train. So if it is 0, it will be plotted with a different color. If it is a 1, it will be plotted with a different color. See this. Okay. So it tells you which sample belongs to which class. Okay. Let me say plt.show also. So you don't see this text. Okay. Typically, if you do plt.show, you will not see this text. Okay. All right. So this is how the data looks like. Let me give a legend also. So let's say this is my scatter plot. I'll give a legend here. This is just specific syntax. You can remember it if you want. Right. So legend elements. And you have to give labels. Okay, what labels you have? So labels will be the unique values in your Y train. Okay, so numpy.unique. Your Y train. You can pass Y also because that also has the same. And you have to pass it as a list. Otherwise, it will throw an error. Sorry. One bracket missing somewhere. Yep. Okay. So if you see carefully, 0 are the actually cancer patients. I mean, it may not look like much, okay, but yellows are more. Please note that yellows are more. Okay. All right. So if you look at this curve, right, our objective is essentially to draw a line which separates blues and yellows. Do you see that there are some blues which are overlapping with yellows here?
Yes.
So do you think a line is sufficient to separate this data?
No.
No.
Probably not, right? Even a curve will not be able to separate this data correctly, right?
Yes.
Look, I mean, whatever curve that you draw, some points, because they're overlapping, so misclassifications would be done for sure. Okay. All right, so I'm going to draw a line here. So I hope you remember what is the equation of the separating line. Anybody who remembers it? Equation for the separating line.
Theta naught plus theta 1 plus theta 1x theta 2x equals
Equals to?
0.5.
No, that was for linear regression.
Hmm.
What was for logistic?
It was summation of minus summation of yi.
But this is what it is, equal to 0. In linear regression, it was equal to 0.5. In logistic regression, it came out to be equal to 0. So this is your intercept, which is your theta naught, by the way. So I'm going to store your intercept. Okay, so let's say this is your theta naught. Okay, and let me show you the coefficients. How many coefficients will we get? There are two features.
2.
Two coefficients. Okay, you can see this. So let's get the first coefficient. To get it like the first, this is the first coefficient. Let's say this is theta 1. Okay. Okay, and let's get theta 2 as well. This is your theta 2. Okay. Okay, now that we have our coefficients, okay, I have a question here. Okay, please see to this carefully. Okay, I want to plot this line. Okay, I want to plot this line on this theta 0 plus theta 1 x1 plus theta 2 x2. Okay. Now this can become complicated for some people to understand, so please try to follow. So can I say that I want to find the pairs of x1 and x2, which when substituted in this line should give me equal to 0? Yes or no?
Yes.
Think about what I just said. I am saying that I want to find the combination of x1 and x2, which if you substitute in this line should give you equal to 0, which means that the point lies on the line. Yes or no?
Any one of the specific value which gives 0.
Yes, I want to find one pair for, so this could be say A1, okay, and this could be say A2. I want to find A1 comma A2 such that if you substitute A1 in x1 and A2 in x2, the LHS, if you substitute, right, it should give me equal to 0, because that's what indicates the point lies on the line, right? Yes or no?
Yes.
Okay. So can you give me a way how to find it? Think. Can you find any possible pair which lies on the line? This is actually a simple maths question. Think. There are infinite points. Think of that. Aren't there infinite points? There are, right? You have to find one of them. How would you find it? That's the question. Okay.
By substituting only we will get it, right?
Okay. Do you think that you can substitute x1 and x2 in as anything and it will substitute, it will satisfy equal to 0? No, right? No, I hope that makes sense. But you have a very nice idea here. Think. The idea is to substitute, but to substitute what?
One we can substitute.
Yes,
One
that's
zero.
the idea. One you can substitute
Yeah.
and find the other one. Okay, that's the main idea. So what I'm going to do is I'm going to write x2 in terms of x1. Please see to this carefully. Okay, that's the beautiful idea that I'm looking for. Okay, so do you think I can write it like this, that theta to x2 is equal to, I'm going to take this to the other side. So this will become equal to minus of theta 0 minus theta 1 x1. Yes or no? Does this make sense? Yes, people. Okay, and then I'm going to take this theta 2, okay, and divide this theta 0 by this theta 2. Okay, and similarly divide this theta 1 by theta 2. Okay, does this make sense to everyone?
Yes.
Now, if I put something in x1, don't you think I will get corresponding value of x2?
Yes.
Okay. All right. So let's put something in x1 and we will try to put it intelligently. Okay. So where do you think the line would actually pass from? It will be something like this, right? Yes or no? Are you able to see the cursor? I'm trying to separate this using the cursor. Okay. So let's say that one of the points is maybe somewhere here. Okay. Where my cursor is. So where do you think this point would be?
110.
110 comma, if you look at the, okay, let's say 110. Let's try to find out what x2 would be for that. Okay. In this equation, let's try to put x1 as 110. Okay. So I'm going to make a list that actually keeps track of this. So this is 110. And what is the corresponding output? This is the output, right?
100.
Okay. All right. And think about that. So I'm going to put this one point here. Okay. And there would be the other point on the other corner, right? Yes or no?
Yes.
And so what would be this value somewhere here? Can you give me a value here? Close to what? 60, 65?
60 close to.
Okay. Okay, let's go with 60. Okay, the other value is 60. And put 60 here. Okay. And let's see, what do you observe? Okay, you observe this. So do you agree that these 2 points will lie on the line? Yes or no? Are you convinced that these 2 points lie on the line? And if I connect them, I will have the separator. Yes or no? This is a simple idea for drawing a separator. Okay, this is a simple idea for drawing a separator. I can do it in much more complicated way as well. Okay, but this is the easiest way, which I feel should be taught. Okay, so I'm going to connect these 2 points. So let's connect them. Okay.
So that 110 we were taking
Just from looking at it. Okay.
Okay. And the 65 also the same, like.
Yes. I think I made a slight blunder. Instead of plotting X-train, I should plot what? Standardized X-train. Okay. This was a blunder which I made. Okay, so we have to change the values. Okay. You can now see that the values are now between, most of the values are now between -3 to 3. Okay. So let's take one of the values close to say 0.5. Okay, and get the results. Okay. So this is a result for 0.5. Okay. This was a blunder which I made. I'm sorry for this. Okay. And the other value would be somewhere probably here. Okay, which would be close to -1. Okay. Let's say -1. You can actually do any value, okay, and just simply connect them. This is the, all right. So I'm going to take these 2 values and connect them. You can do it with the help of plt.plot. Okay, it's not visible. Oh, sorry, I'm doing for std extract. My bad. Do you see this now? This is the actual separator that logistic equation gets you. And do you realize that, okay, this is the best separator that you can get? Yes or no? Okay, if you would have shifted this line to the right or the left, don't you think more points would be misclassified?
Yes.
Okay, I mean, if you actually take it to the right of this yellow point, you are thinking that one yellow point would be correctly classified, but there might be many blue points. These maroon points which are here, they will get misclassified. So the number would be more. So logistic regression is actually giving you a good result right now. Does that make sense?
Yes.
Okay. Now, this is just to show you, okay, this is what the separator is. Okay. All right. Do you want me to extend it or is this fine? Do you want me to extend it or is this fine?
The line you're asking.
Yeah, the line.
It's fine.
This is fine,
That's
right?
fine.
Okay, this is just to show you, okay, this is what you can actually put the value close to say, maybe say 0.89, okay, and then, I mean, extend this line, okay. All right. This is the separator that you get. Let's see what other things that we can get from this model. So one of the things is we can get the prediction, right? So just to get the prediction, I'm going to show you one test sample. Okay, look at this. I'm going to take the first test sample rather. Okay, this is the first test sample. Okay, carefully see this. Now, how do I know this is a purple point or a blue point? And by the way, this is the actual value of this test sample. It's a 0, by the way. Actual value is 0. Okay, actual value. Using the separator, how would you decide if it is 0 or 1? Okay, you remember the equation of the separator is this, right? Theta 0 plus theta 1 x1 plus theta 2 x2. Where is it? Here, right? So if I substitute the point in this line, okay, if I substitute the point in this line, let's see what do we get. Okay, I'm going to substitute this value here. Okay, I want you to carefully observe what happens. Okay. And x2 is this. Okay, if it's higher than 0, what should be the prediction? See, at 0, you are not able. If this is a separator, can I say that at equal to 0, I am unable to say?
Yes.
Yes or no? If it is higher than 0, what should be the output?
If we class 0 in this
1. Here the slope is negative. Okay. All right. Look at this. Okay. So it tends to be -5, which is less than 0.
Yes.
So less than 0 means what? 0. See, what is the separator saying? Separator says that the value is equal to 0, right? Which means that the point lies on the line. What is meant by a separator? Separator means that on this line you will not be able to decide. Yes or no? So anything above it is going to be class 1, anything below it is going to be class 0. Look at the value that you generate. It is coming out to be -5. What does that indicate? It is below the line or above the line?
Below.
Below. So what it should be predicted as 0, right?
Okay.
Okay. Let's try to see what is the probability for it. How do we compute the probability? Yes, people, how do we compute the probability? Sigmoid of this. Yes or no? Okay, we compute the sigmoid of this, right? And what is the formula for sigmoid? 1 divided by 1 plus
minus
numpy dot exponent, okay, of minus of this value, right? Yes or no? Does that make sense? Okay. So this would be the probability score. Let's see what is the probability score. This is in favor of class 0 or class 1. Think about it.
0.
0.
This is in favor of class 1.
Okay.
Yeah, positive, right?
So if it was greater than 0.5, what would you predict as? This is the probability score which is coming, right? Yes or no? This probability score should be a value between what? In what range should you get this value? Think about this.
1.
Between 0 to 1.
Yes.
It's a probability score. So at what value you will say that, okay, it is class 1. At what value you would say it is class 0? If this value that you get, let's say this value is x. If this x was greater than something, then you will say it is class 1. Otherwise, you say it is class 0.
Yes.
What is it that value? What is that value? What is the threshold?
In this case, it's 0. confused, actually fully confused.
You have forgotten everything that we have discussed. Okay. See, this is the probability score for a sample. Okay. I want to predict if it is belonging to class 0 or class 1. You know that any probability score will be between 0 to 1, right?
Yes.
Yeah.
Okay. Let's say a value X is coming to you. How would you say that it belongs to class 0 or class 1? What do you do?
0.5 only.
0.5 only. Is it greater than 0.5?
No.
Less.
All right. Okay. You see that it, so what should this belong to? Class 0, right?
Yes.
Yeah.
But it belongs to class 0. Okay. I'm going to show you this is the probability. And so this probability is in favor of which class? So, okay, let me try to interpret it. Okay. How much confident you are in favor of class 0? Or first class 1. How much favor in favor of you are in favor of class 1? How much confident you are in favor of class 1? This much, right? Yes or no? This is the favor in favor. This is the probability in favor of class 1, right? Yes or no? Think about this. Okay, you are yourself saying that this is class 0. So how confident you are in favor of class 0? 1 minus of this value, right?
Yeah.
Yes. Yes. Yes.
So this is the probability for class 1. Do you get that? The output that we are getting, it is in favor of class 1, not in favor of class 0. Okay. See, you are getting a probability score for class 1. If this probability score was actually greater than 0.5, you will say it is class 1. If it was less than 0.5, you will say it is class 0. This is your confidence in favor of class 1. Okay, this is your confidence in favor of class 1. So I will say that I am 0.2% confident in favor of class 1. So how much confident I am in favor of class 0? 1 minus of this value?
0.998.
0.8.
99.7%, something like that.
Yeah.
Yes, sir. 99.7% approx. So you are very, very confident this is class 0. And it looks like that you are very, very close to 0, right? Yes or no? So you are very confident that this is class 0. Is this clear or not?
Yes.
Okay. So the probability that is coming is always in favor of class 1. Okay. So 1 minus of this value. Okay. 1 minus of this value. See, again, I'm repeating the theory part that we did. Okay. This percent. Okay. If you multiply this with 100, you will get the percentage. Okay. This is the confidence in favor of class 1. Sorry, in favor of class 0. Okay. All right. You can interpret it like this. Okay. Let's see if the model gives us this or not. Even though I've explained you the theory part of it, which function do we use to predict the class label? How do you make predictions from machine learning models? Which function do we use?
Model.predict.
Model.predict. You'll use the model.predict function. Okay. So what should I pass? I should pass this sample. Yes or no? Okay. What is our prediction coming as? 0 or 1? What would you finally predict if this is the confidence in favor of class 1? What would you finally predict? 0 or 1? Think about this. What would you predict? Would you say it is class 0 or class 1? 0 only, right? Because it is less than 0.5. Okay. So, see, please note that if you are passing one sample, you have to reshape it. Okay. If you're passing one sample, you have to reshape it. Okay. So, because if I do it like this, it will throw another. Okay. You have to reshape it. Okay. For one sample, there is this problem. Okay. Okay. Oh, sorry, it would be 1 comma minus 1. Okay. Do you see that it predicts it as class 0? Yes or no?
Yes.
Okay. Now I'm going to show you the probabilities that we obtained, right? These are the same probabilities that this model will also return. So there is this function called as predict proba. Okay. This returns the probabilities for you. It will give you two probability scores, one for class 0 and one for class 1. Okay. So which probability score is for class 0? This is the one. Which probability score is for class 1? This is the one. Do you get it?
Yes.
Okay. You'll see these two values will be printed. Okay. Do you see that? Confirm it.
Yes.
Okay. Otherwise, what I've told you is incorrect. Okay. So you can actually see now, okay, if you look at these class probabilities, what should be your answer? First probabilities of class 0, this is for class 1, which is higher?
Class 0.
So you can say answer is class 0. Okay, you can run it on the entire set. Okay, you can run it on the entire set. Okay, you can run this on the entire set, and this will give you a probability score for every sample. Okay. Okay. If I ask you what is the answer for the second one, what would you say? Which is higher for the second sample?
Class 1.
Class 1. So that will be the output. Okay, that will be the output. You can say that. Okay, I'll show you. Okay, I'll just use the predict function. This will predict class 1 as the output. Okay, look at the second output. Does that make sense?
Yes.
Okay. Any questions up to this point? Please ask. If it is not understood, let us spend some time in understanding this. See, please note that you can determine the class label from the separator also, from the probabilities also. So if this value, I'll just mention it again. Okay. Assume, okay, think about this. If this value is equal to 0, would you be able to say it is class 0 or class 1? This is the ideal separator. Please remember this. So if the point lies on the line, would you be able to determine no, right? Okay. So if it is greater than 0, what are you saying? If this value is greater than 0, this means that it is belonging to class 1. Okay. If this is greater than 0, this belongs to class 1. Otherwise, it belongs to class 0. Okay. Else it belongs to class 0. Basically on the other side. Okay. Else it belongs to class 0. Is this part clear?
Yes.
Okay. All right. Now you can also use the probability score to interpret this. Okay. So we are finding the probability score. So whatever the probability score would be, it is in favor of class 1. Let's say it came out to be 0.6. What can I say? I'm 60% confident in favor of class 1 and 40% confident in favor of class 0. So what you should predict as? Which is higher? Class 1, right? Okay.
Yeah.
Let's say you get the number 0.2. You will say that I'm 20% confident in favor of class 1 and 80% confident in favor of class 0. So what you should predict?
0.
Class
Yeah,
0,
class 0.
right? See, because the threshold is in the middle, right? 0.5.
Yes.
Okay, so you can pick the maximum of the confidence. You can pick the maximum of the confidence. Does that make sense?
Yeah.
Okay. All right.
So if it is 0.2, I'll say
It is
I'm
still
in
class
favor
0.
of class 0. Okay. Okay.
Yeah, you can interpret it like this. Okay. If this number, the probability score is greater than 0.5, you say it is class 1, otherwise it is class 0.
Class 0. Okay.
Okay. And please remember this, you are allowed to change the threshold as per your need, as per your domain, right?
True.
Would you use this model with probability with threshold as 0.5? Think about it. If you were to give the person chemotherapy.
No.
No, right? So you'll use the threshold as 0.9. Okay. Or let's say if I use the threshold as 0.99 or say 0.999, what would you predict it as? The threshold is say 0.9999. Okay. What would you predict it as?
Class 1.
Class
No,
1.
it would be then class 0. Is this number, okay, look at this, okay. The threshold has just increased, okay. If the threshold was great, is your number greater than this number?
No.
No, right. So what will you say?
It's class 0.
It is still class 0, right? If I reduce the threshold, let's say I make it 0.0000 like this, okay. Now what would you predict?
Class 1.
Now class 1, okay. So you can vary the threshold as per your will, as per your domain, okay. Let me say this is the threshold. So you can use both the probabilities as well as the separator value to determine. The disadvantage of using this is we don't get the confidence. So we do want the confidence for each class. That is a good thing to have. Okay. All right. So what should we compute next? See, we have determined what is the actual output, right? Sorry, what is the predicted output for each sample in the test set? So we would want to know how good the model is doing.
How accuracy or
Some evaluation metrics, right? So I'm going to, have you seen any evaluation metric first? Or this is the first time we are doing it?
classification we are doing first.
This is the first time? Okay. Let's start with all the evaluation metrics one by one. So I'm going to show you how to implement. So shall I show you from scratch also, or shall I directly use functions? What would you prefer?
time permits from scratch.
From scratch also? Okay, all right, let's see this. So, okay, how do we compute accuracy? So, let's say, look at this first value, okay? And this is the first value, actual first value. Look at the first predicted value. We got the first predicted value also, right? You can
Yes.
see it from here, okay?
0.
I'll just use this, okay? I'll just use this and I'll print the 0th portion of this, okay? Okay, is the first sample accurately classified?
Yes.
Yes.
Is the second sample, I mean, let's look at the second sample, Y test of 1 and STE test of 1.
Yes.
Is this accurately classified?
Yes.
Yes.
Right? So can I just make a comparison across all of them? And whichever are correctly classified, I will simply count them out, divide by the total number. That would be accuracy, right? How is accuracy defined? Number of correctly classified samples divided by total number of samples. Yes or no?
Yes.
So if this is my actual value, I can actually compare it with the predicted values. Okay, see this. So wherever they match, you will see a true. Wherever they don't match, you'll see a false. Look at this. Do you see there are certain true and false?
Yes.
So wherever it is matching, they are correctly identified. Wherever they are not matching, it's not correctly identified. Okay. If you want to count how many trues are there, you can simply sum them up. True is typically treated as 1. Okay. So 152 samples are actually correctly identified. How many are totally there? Can I say that they will be equal to the number of samples in the test set? Yes or no?
Yes.
How many samples are there? 171. So 19 actually had false. Okay. So I'm going to divide this by shape of 0. This is the total number of samples in the test set. So can I say that this would be my accuracy?
Yes.
Okay. This is your accuracy. This is doing it from scratch. You don't have to do this. If you understand the concept, you can directly use this formula, input accuracy score. Okay. It will compute the same thing for you, which I've done it. Okay. So you can call this function accuracy score on your actual and predicted values. So actual values are in Y test, predicted values are here. Okay. You can save it into preds, predictions, whatever. Okay. And do you see that you get the same number?
Yes.
So this is what accuracy is. Shall we do precision? Okay.
Yes.
All right. Let's do precision also. Okay. So I'm going to do it from scratch, and then we will show how to do it with functions. So precision actually is a class-wise metric. Before that, let me plot the confusion matrix for you. So from sklearn.metrics, okay, we are going to plot the confusion matrix. Okay. So by the way, there are two functions with the help of which you can plot the confusion matrix. This is one, and the other one is confusion matrix display. Okay. This is the another one. Okay. This is the function that you should use, confusion matrix display, because this is the recent one. This function will become obsolete probably next year. Okay. Next year sometime it will become obsolete. Okay. So this is the function that you should use. So I'm going to show you both. Okay. I don't remember the syntax for it, but let me just check it out. Okay. They have very similar syntax, just the arguments are different. Okay. All right. So estimator, X, and outputs. All right. So what you have to do is to plot this confusion matrix. Okay. So the syntax is this. You have to pass the model. This is your model. You have to give him the actual values, the input values, and you have to pass the actual values which are in test set. So the model will be applied to these features, and then the confusion matrix would be plotted. Okay. Do you see that? Is this clear? Do you see that it throws a warning to you saying that this function is going to get deprecated? So use confusion matrix display. Okay. Okay. Look at this. Okay. If I ask you what is this value, what would you say? Interpret it in terms of true positives, true negatives, false positives, false negatives. What would you say?
False negative.
So the true label is 1. It is predicted as 0. So this is falsely identified as negative. Good.
Yes.
Similarly, if you look at this value 98, 90, 96, 98, what is this?
True positive.
Correctly
True positives.
predicted. Yeah, true
Okay.
positive.
one predicted as once. Okay, so this is how you can interpret it as. Okay, I'm going to show you the second function. See, if you want to hide this warning, you can actually import one library called as import warnings,
Warnings. Okay.
and then you will not see that message either. But it's better to not hide the warnings. Okay, because that will help you correct your code if you are using, say, an updated. I mean, if you are using the best resources, I mean, the most updated resources, the packages are updated to the, you can say, the current versions. Okay, do you see that there is no warning now?
Yes.
Okay. Now I'm going to show you this, how to use this confusion matrix display. This is slightly different. Okay. So first you have to do, first you have to make a confusion matrix separately, and then you have to pass this confusion matrix to this. Okay. Okay. Just to show you. So you have to give a, you have to make a confusion matrix first. Okay. Let's see. So how do you make a confusion matrix? I think I can make a confusion matrix like this. So first make a confusion matrix. Let's say our confusion matrix is this. So you can make the confusion matrix from the actual and the predicted values. I believe you can do this. Y-test and the actual values will be in model.predict of standardized X-test. Okay. So I have the confusion matrix. This is a confusion matrix, by the way. Okay. The same thing that you are seeing over here. Okay. Now you will use this confusion matrix display function. Let's import it from sklearn.metrics. Import confusion matrix display. And you pass the confusion matrix to this. Okay, you pass the confusion matrix to this, the CM to this. And please note that if you want to print the labels, okay, you can print the labels also. So the argument here is called as display labels. Okay, so what you should pass to this? The unique labels that you have, zeros and ones. Okay, so I mean, if you had some values, okay, let's say I want to pass the labels. What is 0 right now? What is 0 right now? Having cancer, right? 0 means, so I'll just copy paste these two values. Okay. So you can actually display the labels also here. Okay, so 0 is your malignant. Okay. Okay, I'll just keep this class 0 also as this. Okay. And the other one is the healthy one. Okay. All right. Okay, you have to do plt.show. I think there is one thing that you have to do. Okay, 1 second. Let's say this is a confusion matrix display. I think we have to do this cmd.plot. Okay, and then plt.show. Okay. Do you see that now? Is this clear? I mean, it's kind of overlapping. You can simply remove this if you want. If you remember what it is, okay, you can simply remove this. Okay. All right. So you can use this to, I mean, plot your confusion matrix. Let's see how to compute precision and recall. Do you want me to do it from scratch or directly functions? Precision and recall. I have to run a for loop for that. That's it. Directly from functions, will that be okay? Otherwise, you can compute it from here. Okay, if I ask you, what is the precision from, let's say, class 0? Can somebody tell me what would be the precision from class 0? Look at this confusion matrix, you will be able to tell. 0 is malignant.
4.
54 divided by what number?
4 divided.
See, precision is from the predictions. Yeah, precision is from the predictions. So where are the predictions?
64.
63, right? Predictions. See, these are the true labels, right? On the row side.
Yeah, 63.
63. Okay. You have to look at precision for class 0, the malignant class. Okay. So that would be 54 plus 9. Okay. This would be a precision, by the way, for class 0. So how to do that? You have to go to sklearn.metrics, import precision score. Okay, and you can pass the actual values, the predicted values. The actual values are in y-test, predicted values are in model.predict of
Predict.
standardized x-test. You have to give a label here because that is important. The position label is 0. I want it for class 0. Do you see the same number? Yes, people, is this clear? Shall we do recall also? You can do it for class 1, okay, in your free time. You just change the label and you'll get it for class 1. Okay, let's do recall. So how is recall defined as? For class 0. Recall is in terms of your actual values.
This would be 54.
54 divided by 64. These values. Okay, it is from the data set. 54 divided by 54 plus 10. Okay, this would be the number. So I'll show you okay how to compute recall as well. So this is called as recall score. Simply say recall here. Okay, makes sense? If you want F1 score is what? Harmonic mean of
Precision.
precision and recall. So 2 into what is precision? This number.
1 divided.
Okay, I'm doing it for class 0 only right now because that is the important class. And this is your recall. Okay, divide by
Sum.
recall plus precision, right? 2 PR into P plus R. Or you can do 1 by P, 2 divided by 1 by P plus 1 by R. Okay, both are the same things. So it's 2 into precision into recall divided by precision plus recall. Okay, this is your F1 score. Okay. So you don't have to do this again. Don't write the full thing like this. So just do it like this. Okay, so this is your F1 score. Okay, and just simply call F1 score here. You'll get the same value. Is this clear? Any questions up to this point? Anything else that you want me to do for the evaluation metrics?
No, Sanatan.
Okay. Did we discuss AUC, ROC?
No.
Okay, we'll do that maybe today at the end. Okay, so this is how you implement, say, logistic regression on, but this is the default hyperparameters. Which hyperparameters do you think logistic regression contains? If you remember the function for it. Anybody who remembers it? Okay, what was the loss function name? All these things I ask you to revise. Okay, I mean, so every what was the name for it?
Log, right?
Log loss. Log loss.
Or binary cross.
Or you can call it binary cross entropy. Okay, you can call it binary cross entropy. Okay, so and you can have penalties also with this. Okay, alpha into penalties with this. What are the penalty functions possible? So look at this formula. Okay, so in binary cross entropy there are 2 terms, right? If you remember, term 1 and term 2.
Yes.
Okay, so term 1 was for class 1, term 2 was for class 0. Okay, so you had these weights also, right? W1 times this and W2 times this, class weights. Do you remember it?
Yes.
Okay, so these are all the possible hyperparameters that you'll be using. So let's define our hyperparameters. Okay, I'm going to show you on all the features right now. Okay, instead of doing it for 2 features. Okay, so the first hyperparameter that you see is your alpha. Okay, which is the amount of the regularizer. How much you want to regulate the penalty. So let's see it in this range of. I'll start from 0, which means that there is no penalty, or maybe I'll start from 0.00001. Okay, very little penalty. Okay, and I'll go up to 10, and maybe take 100 values in between. Okay, then I will see the different penalties. So what are the possible combinations? L1, L2, and elastic net. Yes, studied these before, right?
Yes.
Okay, elastic net. All right. Then if you want to give class weights, so I'm going to give this class weight Okay, these are called as, I think, simply, let me just check. Okay. I think they're called as weights, simply weights or class underscore weight, something like that. Okay, I'm just checking. This is called as, do you see anywhere? Yeah, class weight. All right, so provide this class weight. So you have to provide this class weight as a dictionary. So the first dictionary I'm saying is, so which class should get more weight, 0 or 1? Which class should get more weight?
0.
0, right? The minority class, the one people having cancer. So let's say I'm giving twice the weight to class 0. So this is the class label, this is the weight that you are giving. Okay, so this is basically W, you can call it W0. Okay, this is W0, the weight for class 0, and weight for class 1 is 1. Okay, I'm just going to show you for two combinations. Okay, so class 0 has weight maybe say 1.8, and the other one has weight maybe say 1. Okay, you can try putting in different weights if you want. Okay, and maybe I'll give like a common weight for both of them. So none means that there is similar weight. Okay, both of them have equal weight. None means by default equal weight. Okay, for elastic net, what is the name of the parameter?
L1 ratio.
L1 ratio. So give L1 ratio as well. So I'm going to give L1 ratios between 0 to 1, maybe say 5 values in between. Okay. Anything else? Let's see if we can provide anything. Penalty, duality is not needed. Tolerance you can actually reduce if you want to run the model for more iterations. Okay. And now there is one thing which I forgot to mention. This C that you see, right? There is no alpha. Do you see there is no alpha here? Is there any alpha here? No, right? So C is actually the inverse of alpha. So you can think of this by dividing this whole equation by alpha. Okay. So 1 by alpha is called as C. So you can say that C is multiplied with this quantity. Okay. And this is like this. So more the C, less the penalty. Okay. More the C, less the penalty. So you can keep this as C instead of alpha. Okay. I'll just mention it. C is the inverse of the regularizer. Okay. All right. Okay. So we are trying with different values of this C. Okay. Anything else that we can use? You can see the solver is currently this LBFGS. This is actually a advanced solver. You will see gradient descent, different forms of gradient descent. Let me show you. There are these other solvers also. Where is it? These are the solvers which you can use. Okay. So not every solver is, you can say, applicable to all the different penalties, because some of the penalties are not differentiable. So this is conjugate gradient. It's a variant of stochastic gradient. This is stochastic accelerated gradient, a variant of gradient descent. Okay. So out of all of them, can you tell me which one is compatible with all? Out of all of them, which one is compatible with all?
Last one.
Last one. So when you're calling a model, right, call it with this. Otherwise, it will throw errors. It will throw warnings to you. So when you're calling this logistic regression model, right, let me call it logistic regression. Okay. So give a random state because it will initialize the theta somewhere. Okay. And you call the solver and keep it as saga. Otherwise, it will throw an error because you're searching for all the different penalties. Okay. Anything else worth looking at? If you want to increase the number of iterations, okay, you can just change this. So I'll just make it say 1000. Okay. Okay, and maybe say tolerance limit, I'm going to set as this. So whichever is achieved first, it will stop there. Okay, whichever is achieved first, it will stop there. Okay. I'm going to talk about this multi-class soon. Currently, we are doing binary, so we don't need this. Okay. So do you, I mean, I hope you know that in gradient descent, we start from some random thetas, right? And then we optimize the thetas. Yes or no?
Yes.
Now, imagine that you have trained a logistic regression model before. So would you want to start from scratch again, or would you want to reuse the weights that you obtained, say, when you retrained the model, say 5 days back, when you trained the model 5 days back?
Reuse.
Reuse, right? So you can
Yeah.
pass that model here, the previous model. Okay, just pass an instance of the previous model here in warm start, and it will reuse the weights as the starting point. Is that part clear?
Yes.
Okay, just assign that previous model instance, the object of the previous model logistic regression here. It will start using the same weights. Okay. Njobs is a hardware parameter. You can set it to -1, which will utilize all the hardware cores. See, currently in your computer, you have like a processor, right? Which processor are you having? i3, i5, i7?
I'm having i3.
So i3 has, depending on what generation you are using, it has 4 cores. Okay. Some of them, they have 6 cores as well. But let's say if you're using 10th generation
i3
or
6 core
lower,
I'm using.
so you have 6 cores. Okay. So if you set it to -1, it will use all the 6 cores parallelly. Okay, that will fasten the process for bigger data sets. For smaller data sets, I don't advise to use it. Your system will start lagging.
Okay.
Okay. And L1 ratio is the parameter for your, elastic.
1 minute. I'm sorry. Like, if I'm using it for a small data set means my system will start to lag.
Yeah, it will start to lag. For that limited duration, it will start to lag. The reason for that is, see, you're thinking when many people are actually doing the same job, don't you think they have to communicate also?
True.
So communication is actually a bottleneck. Okay, so for small data sets, everyone would do their job quickly, but to aggregate them, okay, it will take more time. So are you aware of the computer architecture about the system bus and everything?
Yes, yes.
So think of this as when the information travels through the system bus, right? It takes more time in comparison to the computations. Okay, so if your data set is very small, computation will be done quickly. It will take more time to
Yes.
aggregate the information. Okay, so that's
Okay.
I think I don't advise that. Instead, if you would have used a single processor, it would be still more quicker than using all the 6 processors. Okay,
Okay.
the aggregation would take more time. Okay, I mean, when I'm describing it, it's very simple, but there are a lot of entry cases. Okay,
Okay. But for larger sets, it will work fine.
for large data sets, you will actually have a speed up of, if you have 6 cores, you will have a speed up of around 2.7 or so. So
Okay.
2.7 times the time you will save. So if it took you, say, 10 minutes, it will now take you around 3 minutes or so. 3.5 to 4 minutes, you can say.
Okay. Okay. Get it.
All right. So these are the parameters that you have. Okay. So when we are going to say do cross validation, so I need to specify the cross validation type. So I'm going to give you the best model right now. Okay. So let's go to model selection, and we will import this time stratified k-fold. This is the variant of k-fold where every fold has the same distribution. Okay. And we need to import this randomized search CV. I'm not calling with search, otherwise it will take more time. Okay. So let's call stratified k-fold, define the number of splits. I'm going with say 10 folds. Okay. Call this randomized with search CV function. Okay. What do you think we should use? Do we have to standardize or normalize? We have 30 features. Yes or no? We have 30 features. Do we standardize? I mean, do we scale the features or not?
Yes.
We do.
So if you have to scale the features, then apply the model. So I need something. What is it that I need? While implementing, I am doing these steps. So where do I use these steps in the implementation?
First I standardize and then first I scale and then do
A model application, right? So which function do I need?
standard scaler.
No, that I need. Okay, that is for sure. But when I'm defining these steps should be passed to what?
Pipeline.
Pipeline. You need a pipeline for this. Okay. So everything we have seen before, it's just that you have to repeat for every model. Okay. So let's import pipeline. Okay. In pipeline, you will call the steps. Let's define your steps. See, the steps remain the same for every model. Each step is going to be defined as a tuple. So the first step is standard scalar. So define the standard scalar. Okay. Standard scalar
The name and then it should be in one topic.
followed by the function name. Okay. And the second one would be the model, right? Let's say we are using logistic regression. So this is the name that we have, and this is the model that we are going to pass to it.
2 brackets are extra. I think the SS then bracket.
Okay, just let me see. There's no, I mean, no need for this. It will still not throw an error. I need one more bracket maybe here if I would have done this. You're right. Okay, but this is fine.
And even the one before standard.
Thank you. All right. Anything else that we should correct here? No, right? This seems okay. Okay, maybe it will throw an error and then we'll figure it out. All right. So these are your steps. Let's call this as your pipeline. Now, how do I know that the parameters are for logistic regression?
In
There
the
are two things, right? So what should we do?
we have to give LR underscore.
LR underscore underscore, the name followed by 2 underscores. So to ensure that the pipeline knows that the parameters are to be passed to the logistic regression model. Okay. So call this randomized search CV. Okay, let's call it say as RCV. So first thing is you will pass the model that you have. The model is, so basically the pipeline in this case. Then you will define the parameters. So the parameters are given in this parameters distributions. So instead of calling it as params, I'm going to call it as hyperparameters to avoid any confusion. Okay. So these are my hyperparameters. Okay. Parameters are something that we determine, right? And the cross validation is stratified k-fold. Scoring technique is, which scoring technique do you want me to use? Which scoring technique do you want me to use? Precision, recall, accuracy. What is it that you want me to use?
Precision.
Okay. Please note that if you want to use precision here, okay, by default, this precision will use label as class 1. Okay, it will not use the default POS label is class 1, not class 0. Okay, I frankly do not know how to set it to class 0, so I'll have to check online. Okay, so what I typically do is I make my own scoring metric and then do it. Okay, so currently what I'm going to do is I'm going to do it for accuracy, and then I will show you how you can make your own custom models, custom scoring functions as well. Okay, so currently this is my scoring metric. I think this is it. I'll show you how to do it for precision and other things as well. There is some spelling mistake. Yeah, stratified. Stratified. Okay, cannot import. Again, spelling mistake is there. Stratified. One more mistake is there. Oh, sorry. Randomized.
Randomized.
Yeah, I just wrote it randomized search. My bad. Anything else? From SQL.
Pipeline. Pipeline spelling was incorrect.
Spelling mistakes are there.
Yes.
Okay.
That happens like while we typing too fast.
Okay, here also there is a pipeline mistake. Okay, this is running. No, not running. Okay, it didn't run or what? What's the problem? Oh, I didn't fit it. No, I didn't fit it. Okay, this ran. I didn't fit with my data. Okay. Okay, 1 second. There is a problem. The problem is in this fit. Let's see what is the problem. So there is this penalty is the which is mentioned incorrectly.
Penalty, it was mentioned. I think.
Penalty. Okay.
Penalty.
Okay, this is running now. Hopefully this will run this time. Okay, this is done. So RCV dot best params. Okay, and let's say the best accuracy, the best score.
Sanatan, can you please zoom in the page a little bit?
Yeah, I'll do. Yeah. Okay.
Okay.
So this is the best accuracy over 10 folds. These are the best combinations. Okay. Now I'm going to show you how you can pass this precision here. Okay. So what you can do is you have to define your own scoring metric. Okay. So you have to define your own scoring metric. So how you define your own scoring metric is you have to first define a function. So what would you call this function? Let's say precision for class 1. Okay. Does that make sense?
Mhm.
I'm defining my own function. You have to pass two values, actual values and the predicted values. Okay. Actual values and the predicted values to this. Okay. All right. So from sklearn.metrics, okay, I'm going to import this. I'm going to import precision score. Okay, and I'll compute the precision score from class 0. Okay. Import the precision score from class 0. So y test and y hat. So y hat are the predicted values, y test are the actual values, and POS label is this 0. Okay. Is this clear? And I will return the precision score. I'll return this precision score. Is this part clear? Yes, people.
I more generalize this function by passing this position label as an argument.
No, when you are making a scorer, right, it only accepts two argument, actual and predicted values. See, I'm going to pass this precision underscore class 1 here in the scoring metric. So there I don't have any way to, pass the
argument.
right? Okay.
Okay.
Okay. So I'm just going to pass this name. Okay. That's why I kept it here. Okay. Maybe say position of class 0. My bad. Okay. Now, so how do I know that it's a scorer function? See, it's a generic function, right? So there is something called as make scorer. So you have to make the scorer. Okay. And that scorer can be passed. Okay. 1 second. So this is called as make scorer. Okay, 1 second. You have to import this. So import this function. Okay, and you can say make scorer of this function that you created, precision of
Precision of class 1. Sorry, class 0.
class 0. See, currently, do you see there are certain arguments? For example, greater is better. It should be true, right? Higher the better, right?
Yes.
Okay. Currently, we are passing actual and predicted values. Do I need probabilities? No, right?
No.
Do I need any probabilities? No. Do I need any threshold? No, right?
No.
Okay, so that is why if you want to have probabilities and thresholds, just provide the probabilities. Okay, is this clear? If you were to create your own function which works on probabilities, okay, you said need probability as true and need threshold as whatever threshold that you want to make a prediction. Okay, I'm saying, okay, just let me see. Okay, there's an example here. Yeah, so this is the name for this.
So the threshold value that we discussed, we change as per the domain. That threshold value we specify here in the score.
I didn't get you. Can you please repeat?
Like the threshold value we discussed, right? We as per the domain,
The value, yeah, as per the domain that you can specify here.
that threshold we are specifying over here in the mix.
Correct. Okay. All right. So let's call it, say, precision class 0. This is the scorer that I created. Okay, is this clear? And now you can run this on the precision of class 0. Okay, everything that we did, okay, you can run on this scorer. Okay, so since you said you wanted to do it for class 0, I can pass this precision of class 0 here. There's a problem. Let's see what the problem is. Is not a valid scoring value. You sorted. Okay, just a second. Okay, just give me a sec. Okay, I can do it like this. Because I'm returning this, right? Okay. Just a second. Oh, I need to define that. Okay, otherwise, give me a sec. Okay, let's see. How do they define this? F beta score and make scorer. Okay, let's just use them F beta score here. Okay, just give me a sec. Okay. Let's see some examples. Okay, they must have defined using the make scorer. Okay. So where is this mean pinball loss? Just a second. Okay. Okay, got it. I think I have to do it like this. Okay, I have to pass the arguments. It seems that I have to pass the argument. One second, let me just close this. These are the arguments that I have to pass. Okay, one second, score function. It's y and y pred. Okay, this is a signature. It's not. Okay, just a second. Score function y pred and k arcs. K arcs. Okay. What I did was correct then. What is the problem? It's not y hat. Okay, I think they expect y and y pred. Okay, all right. Yeah. What I did was actually correct. I just need to change one thing. Yeah. This was the actual syntax, y pred. It expects it like this, okay? Otherwise, this is not going to work. So still the same error. Just a second.
Do we have to negate it over here? Like
Where?
the positive matrices are not used, like we do for mean absolute error, the scoring metric we use.
No. That is, these are all positive metrics, right? So positive metrics need not be negated. Okay, just give me a sec. There might be a way to overcome this. Okay, just a second. It's showing me. Okay, just a second. Let me just search it like this. There might be a way to overcome this. Okay, I got the problem. I'm passing the name as in quotes. That's the problem. See, that was just a silly mistake that I did. See, this was getting passed as a string. All right. So it is computing the precision for class 0. So previously, whatever you were doing, that was also correct. Okay. It's not because of this. Okay. Ooh, okay. So this is the precision for your class 0 over 10 folds. Okay. This is your best score. So best parameters. This is your best parameters. Okay. All right. So if you want to do it for class 1, just replace position label. So if you want to just do it for class 1, you just say precision here. If you want to do it for class 1, you will just have to say precision here. Precision. Okay. This will do it by default for class 1. Okay. Or anything else? Yes.
So that means we need two randomized search CV operations, one for class 1 and one for class 0. We cannot have both of them.
Name together. No, you cannot.
So in that case, will it be good to divide my, like, Y is my very big data, but I'm just passing only the label 0 records for the randomized search CV when I'm doing precision score of class 0. So should I restrict my data?
I didn't get you. Can you elaborate a bit, maybe?
Like when I'm doing precision for class 0, in that case, should I just pass that data from my test set, which has you say class 0
No.
as my
Right. I mean, the function automatically, even though it computes the results on everything, right? I mean, do you want to save time? That's what you're saying?
yes.
No, this function will not do that. I mean, this is not that intelligent. Okay. And there is no way that you can specify from the set that you should pass this or that. So it is passing everything, getting the results in forms of zeros and ones, and then looking at only zeros if you were to do it for class 0.
Okay.
Okay. That's what you're saying, right?
Yes.
I understand what you meant, but the function is not that intelligent. If you want to create such a function on your own, you can do that. I can do it for you if you want. Okay, it's pretty easy to do. I just need to ensure that condition should be met.
If condition, if the outcome
Condition is met. Yeah. But I have to write a specific code for first getting the train and test indices from the stratified k-fold. Do you want me to do that? I can do that.
No, that's fine.
It's actually easy to do, not that hard. You just need this function. Okay, I'll just tell you what function.
Instead of doing it in 2 split ups for class 0 and class 1, you're saying that like we can able to do it in one set.
No. What she's asking is, let's say if you do stratified k-fold, right? Let's say 10 times.
Okay.
So for every partition, you are doing say train test, right? For every fold, you are doing train test.
Yes.
So in the test set, let's say if I'm doing precision, okay, do I actually need samples of say, let's say I'm doing it for class 0. Do I need samples of class 1 while I'm computing my predictions?
For class
No.
0, you're computing.
If I'm doing it for class 0, do I actually need samples of class 1?
No.
No, I don't, right?
Yeah.
It's just that any other, but you have to keep track of the indices. Okay, that would be challenging part. See, in precision, when you look at the precision, right, you will be getting output of every sample, right? So you have to match the index, right? If the index is correctly matching or not. If the index is not matching with the actual outputs, then you will say precision is not good for that sample, right?
Yes.
So you have to keep track of the indexes. I'm just showing her there is this function which can help us achieve this.
Okay. So while we were calculating for class 0, like we can, we also need to keep the track of the class 1 indices so that
Indices.
our output will be.
I mean, you can actually correct the correct precision, compute the correct precision. Okay.
No.
This is the function that you need. Okay. This one. You can do this with this function. Okay. It will give you the train and test indices. You have to keep that in mind.
I've done this thing.
Okay, anything else about logistic regression? Yes, anything else about it?
No.
Okay, all right. So I'm going to show you SVMs, even though we will discuss the theory behind it at the end of the course. Okay. I've given you an intuition, okay, how to use, what SVM does, it selects the most important points, okay, to find your decision boundaries. So I'm directly going to show you how to tune it, okay. So go to sklearn.svm and you can import this support vector classifier. So this is your model support vector classifier. Okay, so I'm going to show you some of the parameters. So one of the parameters is this kernel. Okay, and this time I'm going to call it maybe say SV support vector. Okay. So in here, this, it is better to normalize for this. So let's use min-max scaler. Okay. All right, let's pass the kernel parameter. There are multiple kernels that are available that you can use to tune the model. So one of them is RBF. Then you have, this is called as radial basis function. I'll discuss everything in the fag end of the course. Okay. And then you have polynomial kernel, which is also called as this poly. Okay. So these are the kernels that I'm going to use. We will see parameters like C and all that. Okay. So kernel we have used, let's go with C. I shouldn't have changed this. Maybe so I'll just take C. So I'll start from 1, go up to say 100. Okay. Maybe say 100 values in it. Okay, this is fine. Maybe say 0.1. Okay. Okay, anything else? Degrees for polynomial kernel, if you want degree to quadratic, cubic, and so on. Okay. This gamma is for RBF. I'm actually looking at, okay, if you need something else, you can specify the tolerance here itself. Here you can specify the tolerance. So if it is lower, the algorithm will run for more steps. Okay. Max ITR -1 means that it will run till the tolerance is met. Okay. Anything else? These are all hardware parameters. Class weight is there, so let's keep the class weight as it is. Okay. Okay. This is your multi-class data. This is for multi-class data sets. If you have more than 2 classes, I will talk about this. Yeah. Have we discussed strategies like 1 versus 1, 1 versus the rest, and not? Have we discussed these strategies, like how to apply binary classifiers onto multi-class data sets? Does anyone remember?
No.
Okay, we'll discuss that today. So this is a parameter required only for when you have more than 2 classes. Okay. All right. This is enough. So these are the parameters that we are going to try. Okay. Okay. Right. Just let me see what happened.
We are giving the L1 ratio. Do we have to give the penalty?
No, I removed it, right? L1 ratio. Look at this. I didn't give L1 ratio. So here there is no penalty in support vector machines. The model has a different loss term for this. Okay. You will see, I mean, when we look at the optimization, right, it is actually only having L2, not L1. Okay. It doesn't have, it's very similar to L2. It doesn't have L1 at all. Okay. And so no elastic net. Okay. I'm going with, say, accuracy currently. It looks all right. Just let me see if your S is small. Okay, support vector machines, max ITR. I'm just going to omit. Solver is not needed. Okay, was there a random state here? Okay, yes, there is. So we should get the same results. Okay, let's solve it. Okay, this is done. So this is your best parameters. This is your best score. So this is how you implement SVMs. Okay, I'm going to show you a certain thing with SVMs. So at least you know what are the you could say the best samples that are being used to figure out the decision boundary. Okay. So let's call this model SVC, the basic model. Okay. Let's fit it onto our data set. I did the train test split initially, right? And I standardized. I'm going to use the standardized one. Okay. So you will fit the model onto the standardized data. Okay. Now I'm going to show you certain things about this model. So you can actually predict using the same way that you were doing. Okay. So you can pass the test sample, it predicts it for you. Okay. If it is belonging to class 0 and class 1. Other things are like, so this also gives a decision boundary, which is the same thing as sorry. So currently you need to do one thing. By default, there is this argument called as kernel, which is RBF by default. So because it is RBF by default, it will not give you coefficients. It will work only with linear, by the way. Okay, it will work only with linear. Okay. So you have these coefficients with the linear kernel only. Okay. By default, this kernel is RBF. Do you remember I spoke about this concept called as projection? When the data is not linearly separable in the original dimensions, SVM makes use of kernels to project the data onto high dimensional space. Do you remember this concept? I spoke about this in the last class. I showed you this figure of a bowl.
Yeah.
Okay. So when your kernel is linear, basically you are trying to draw a line in the original dimension. When your kernel is RBF, the idea is you are projecting the data onto infinite dimensions. And in those dimensions, you are trying to find a linear infinite dimensional hyperplane, which makes the data linearly separable. So because you don't know what those infinite dimensions are, that is why it is not returning the coefficients to you. Okay. So it will only return it for the linear kernel, not for any other kernel. Okay. Okay. There is one more argument called as probability. So if I show you, okay, in logistic regression, you have this predict proba function, right? Yes or no? Which gives you the probability score for each class. So this also has it, but this will, if you are using it right now, it will throw an error. Okay. So what you need to do is there is an argument called as probability here. And you need to set it to true. Actually, this is a little slower when you compute the probabilities. Okay, so by default, this has probability set to false. So if you set it to true, now you can compute the probabilities as well. Okay, does that make sense?
Yes.
Okay, so these are some design constraints which people have, put for SVMs. By default, this probability is false. You need to set it to true to get the probabilities. Okay, I'll just make a comment here. All right. Okay, that is one thing. Now you may want to know what are the best samples that are being used to find the separator. So I hope you remember the concept of support vectors, the points which are useful towards the orientation of the line. So you can get the indexes of those just by doing this. I think it's called a support vector indices or support vectors indices. It's called a support vector indices. 1 second. Or maybe support vectors. Does it directly give you the points? It's underscore. Just a second. Okay. Yeah. So it gives you all the points directly. So it is telling you these are the points that are used, which are the support vectors. It's using a lot of these points. Okay. It's using a lot of these points. Do you want me to highlight these points on the data set? So that you can see actually those are the points which are being used. Shall I do it with a red color?
Yes.
Okay.
Okay. Yeah.
All right. So that you can see, okay, these are the points which So I'll do it on this. Okay. Same way you can get the thetas and plot the support vector line also, which is theta 0 plus theta 1 x1 plus theta 2 x2. Do you want me to do that as well? Shall I do it? Shall I plot the line that we obtained for? Okay, let's do that as well. Okay. So let me store all the thetas for this. Just a second. So this is the coefficient. There are two coefficients you can see. Let's store the coefficient 0. Okay. This is theta 1. Okay, let's call it theta 1. Okay. Do you want me to keep the logistic regression line or shall I remove it?
Can remove that.
Okay, we can remove that. Okay, and then you have theta 2, which is this. These are your thetas. Let's get the intercept also. Let me pass it like this. Okay. All right. So first I'm plotting the data and then I'm plotting the line. Okay. So I'll plot the line in a separate way. Okay, because the line would change. Okay, depending on the thetas. Okay. So this is the data that you have. I'm going to plot the line on it. Okay. So the equation is still the same. Okay, the equation is still the same. Where is it? Here. Where did we use this equation? Minus of theta 1. Here. Okay, so I need to get 2 points through which I can connect it. I've already saved my thetas. Okay. So let's store the points. So for -1, let's try to figure out what is the value of the outcome. Okay. So let's do 1 point here. Maybe say at 5 I'll do. Okay. So maybe at say -2 I'll do. Okay. Maybe at -2 I'll do. Okay. So this is around this. And the other value I'm doing at maybe say somewhere here, which is close to say 0.8 or 0.9. Okay.
0.9, okay.
Around the switch. All right. Okay, let's plot this now. I'll just push this cell below. And there's one more cell, right? Yeah. All right. Okay, so this will plot the line for you. Okay, you can see this is the line that you get. Can you see that it's working really well? This has squished the, data in, like, if you see that it's in 1 dimension kind of, right?
Yes.
But the range is slightly haywire. Okay, so don't worry too much. Okay. Now I'm going to highlight those points which are the support vectors in red color. Okay, carefully see this. So TLT dot. Okay, I just want to see. So these are my support vectors. So let me plot the support vectors. Scatter. So this would be all points, column 0, the first axis, all points, the second axis, and the color that I want is red. Okay. So these are the points that are actually making use of. So these are the ones that are close by. So they are the ones which are contributing. Okay. This would be a yellow point, which is actually contributing. Okay. So these are the points that are actually contributing towards the line. Okay. Not the other points. Okay. Not the other. Yes.
There is a like break in the red dot.
This is actually a yellow point, not.
Yeah.
So yellow point should also contribute, right? It's getting misclassified slightly.
Yes. So only yellow points it will highlight, or
No,
the
it's a mixture of yellow and blues. Okay, look at this is the original data.
so
Okay,
it's not use
okay.
the-
I'll just comment these support vectors. Okay, look at this. See the points which are closer. I think there is this blue point here. Maybe it's not very clear here because now the points have been squished, right? This is now between -25 to 125. I'll make it smaller. Okay, so that you can see the variations also. Okay, maybe not from 0.9. Maybe say okay, instead of going from -2, let me make it somewhere here. Okay, so which is around 0. Okay, let's do it. What is the value for 0? Is around this much. This is around 0. Okay, and let's say let's do it for one more. Maybe close to say 0. Maybe say 0.5. Okay. That way you will see that the values are kind of spread out. 0.5. The line will be smaller, but you'll be able to see the stark differences. Okay. Can you see the stark differences now? I mean, I can make it even smaller and then you will actually zoom it in. I can do the log of this to plot.
yeah.
Okay, so that you see the spread. So currently that you are seeing, right, it is spread out between -15 to -10, right?
Yes.
Okay, I mean, you can actually make it smaller. So I'm thinking, okay, 1 second, how should I do it? You need to get the handles. Okay, there is a way to get the handles and squish that range. 1 second. Yeah, it is there. So I want to, I mean, scale Ylem, right? Okay. So you can actually see the subtle difference. Okay. Okay. So what is currently my Ymin? I mean, and this goes from here, right? I will plot it all the values say between -5 to 5. Okay, I'll plot all the values between -5 to 5. I hope, okay, maybe I'll say between -3 to 3 so that you can see, okay, the points are kind of well scattered. Okay, I mean, I have to take the log of it to actually show you the differentiation. But okay, but this is sufficient. Okay, I just want to show you now all the support vectors. So these are all the support vectors which are kind of contributing. Okay, so this is what the line is telling you. See, if you want the support vectors to be very, very small, okay, if you want the support vectors to be very, very small, currently, do you see a large number of points are contributing?
Yes.
Okay,
Yes.
so you can actually, I would say, okay, I'm thinking, so if it overfits, there would be more support vectors. So I want lesser support vectors, so I have to avoid overfitting. So I should reduce the value of C. Let me see what is the default value of C, which is 1. So if I want to avoid this, okay, so increasing C will decrease regularization. So I have to reduce C. Okay, so I'll do this. All right. So there is a
So
C
now
value.
there
Yes.
is a lots of points we're contributing so that there is a chance for the model to be
Chance for the
overfitting, right?
overfitting. Yeah. So I'm trying to reduce the overfitting. Let's say I'm looking for the C value. Okay. And you will see that, okay, thetas are also changing, right? Okay. So this is the outcome. Okay. I mean, I have to change these values also. Okay. Let me just get it. Okay. So this is 0.5. For 0.5, this is the value.
Yes.
Yeah,
And 0.
and 0. And this is the value for 0.
Yes.
Okay. And okay. And let's see how many support vectors do I have? Is it the same? Okay, let me compute the length. Maybe say the shape of it. So 296, and it has become more. Now, previously, how many were there? It was hard to tell, right? Let us plot this. Okay, let us plot this. It's hard to tell. I don't know if it has stayed the same or if it's lesser. Okay. So more points have become, okay, just a second. Okay, if it overfits, then you have more, right? Yeah, you do have more support vectors. So I need more regularization. More regularization will mean that I have to reduce C. Am I saying it incorrectly? Just a second.
C is inverse, right? It's inverse of
C is
L.
inverse of lambda. So that's why I'm saying I reduced C, right? So lambda would have increased.
Yes.
So if lambda has increased, then overfitting would be less,
Jesus.
right? So I did the correct thing. I just want to confirm this, okay? Increasing C in SVMs will lead to the number of support vectors. Hopefully it will automatically fill. Okay, so if you increase C, it's the other way around actually. Okay, it's the other way around. There are fewer support vectors. Okay, 1 second. Let me see in this. Do they mention the now C here is the regularization parameter. No, but it says that it is inversely proportional to C. So what we are saying is true. Okay, let me interpret it. Okay, what this is saying. It's the other way around. They are saying that if you increase C, the number of support vectors would be less. So if I increase C, your margin would be lesser and lesser points would come. Okay, I'll get back to you on this. But from the definition, it seems that you should get less support vectors. But they are saying you increase C, you'll get less support vectors. Okay. 1 second. And we can figure it out, okay, just by looking at this. What's the number right now? Yeah, you have reduced it. Okay, let me increase some more. It has increased slightly. Okay. So there is no direct correlation, maybe as such. Just a second. Okay, I need to see this parameter. Okay, 1 second. The same question which I thought of. Okay, so they are doing this. Give me a sec. Okay. Yes, go on.
So the penalty means I'm moving away from my best fit line, right? Increasing penalty, I'm moving away from the best fit line.
Correct. You're moving away from the best fit line.
But to shrink, to have lesser number of support vectors, I have to move closer to the point. That means I have to reduce the penalty.
Again, repeat, please.
To reduce my support vectors, I have to move towards the best fit line.
What are the support vectors, by the way?
The points that contribute.
Contribute to the line. I don't think there is a relationship, but so I'm trying to understand this. Okay. See, the point is, if you increase C, right? What is the definition of overfitting? Overfitting means that you are trying to learn from the examples, right?
Yes.
You're trying to cram the examples. So if your model is overfitting, it will have more support vectors. Yes or no?
Yes,
Think about
yes.
this, okay? You're trying to cram the examples. So that's why you'll have more support vectors.
Yes.
So my intuition says that if you increase C, say C is inversely proportional to lambda.
Yes.
So you will actually have a much more, more support vectors, right? Yes or no?
No.
Because you're doing lesser regularization. See, what does regularization do? It avoids overfitting, right? Yes or no? Think about this. Forget about like what it tries to do in real world. Think about this. If I increase lambda or alpha, what happens?
But that happens, that scenario is for regression, right? We move.
It happens. No, it's the same for logistic also. Same for logistic also. See, the concept of overfitting says that you are trying to learn more from the examples. Yes or no?
Yes.
You're trying to learn more from the examples.
Yes.
So here the concept is the same, that you're trying to learn the orientation of this from the examples. So if
Yes.
you're overfitting, you'll be learning more examples, right? From more examples.
Yes.
Okay. So I want to reduce overfitting. So if you want to reduce overfitting, what you should do? Increase C or decrease C? C is inverse of lambda.
So
Think
I
about it.
have to increase.
Yes, you have to increase C or see. If you increase C, what will happen? You are reducing the regularization.
Yes.
So I want to increase alpha, right? So I have to reduce C.
But
Yes,
that's
sir.
what like last class we discussed.
Shilpa, you are trying to justify what is happening. Okay.
No. I'm
Okay.
thinking in
So this is like an
I'm
interesting answer. Okay. I'm trying to kind of contemplate. Okay. By the definition of it, what should happen, which is not happening. So I shouldn't justify what is happening, right?
No,
Yes,
I'm
sir.
trying to visualize the last class what you explained us that
Yes,
there is a
okay.
cylinder and in classification we try to move like expand the cylinder and fit the point
Correct.
and
So the
right.
so,
But in case
okay,
of
but in
regression,
the definition of overfitting, what does the definition of overfitting mean? That you learn more from examples, right? You cram more examples.
yes,
So more examples contribute. Do you realize this? Is this part clear or not?
yes.
So if the model is overfitting, it is giving you more examples. Okay. And what does regularization mean? It's a concept to avoid overfitting. So the more you regularize, the less you overfit. Yes or no? Okay. How do I reduce overfitting? Should I increase C or decrease C? Think about this.
If I have to reduce overfitting, then I have to
Think.
yeah
To reduce C or increase C? That's a counter argument that I'm giving.
use my points. To
See, C is inversely proportional to alpha, right? So if you increase C, alpha reduces. So if you reduce alpha, regularization is decreased. You have to increase the regularization. So I should reduce C. Yes or no?
Hmm.
So reducing C will mean more regularization, right? Will mean more penalty. Yes or no?
Yes.
Okay. So if it means more penalty, then I should reduce C. So if I reduce C, which means there is more regularization, which means there should be less number of support vectors now.
Yes.
Okay, but that is not happening. It's the reverse which is happening. Okay, I'm trying to find a counter argument. Does this always happen, or is it like so? That's what this person is trying to explain. Okay, from the definition of overfitting, you mean that you learn from more examples, and those examples are support vectors. Okay, it's the reverse which is happening. Okay, I'm trying to find a logic for that.
But we have reduced it, right? Like I think you have given
I have
0 point something.
Okay, no, I have reduced it. So let's say if I keep it to be 1, okay. So let's say if I keep it to be 1, okay. Let's see how many support vectors do I have. Okay. 120 support vectors. Do you see that?
Yes,
Okay.
yes.
Now the question is, if I reduce C, okay, support vector should become less.
Yes.
Okay, because it is doing more regularization now. It actually increases it. Let's see this. So if our definition is right, then this should decrease the number of support
Decrease.
vectors,
Yes,
right?
decrease.
But it actually increases. Let's see this. Okay, do you see that?
296, yes.
It is
From
increasing.
126 to yeah.
296. So that is what I'm trying to think. Okay, why this is happening? Are we doing something wrong, or that's why I was looking at it. The definition in this SVM sklearn. This also suggests that. See, look at this. So everything that I have told you, right, is correct, but there must be an explanation for it, right? It says that strength of the regularization is inversely proportional to C. Okay.
Must be strictly positive.
Okay. So if you reduce C, then more penalty should be there. Okay. All right. So that is why I'm trying to figure out, okay, why is this happening? Okay. So maybe I'll get back to you on this. Okay. I'll read about it. Okay. Does it stay the same? Because I saw that there are some kind of deviations also. Okay. There are some deviations also in this. So like even if I reduce it like very, very large, now I hope every sample would be contributing, hopefully. Okay. Every sample will contribute, or maybe a large number of samples. It is still 296. Okay. So all of these samples are contributing, which are reds that you see over there.
So like on the time I didn't see that, like you have given the C value is around 1000 or something, right? So on that time, like that was gone down or gone up. I didn't seen
So
that.
if it is lowered, the number of support vectors increase, right? If I lowered it, did you see that? Okay, number of support vectors increased. I made it 0.001. You saw it became 296, right? I'm going to increase it. Okay.
Yeah,
This number will actually go down to 100 or something, 110 or something. Look at this.
Okay, so the logic was working, upside down now.
It's upside down. Yeah, it's the contrapositive of what I thought. Okay. So I'm trying to figure out why is this happening? Okay. Or is this true for every data set? Or there is no generic relationship? That's what I'm trying to figure out.
Okay.
Okay. Because see, you cannot just rely on these answers all the time. Somebody has posted it, right? And only 8 people have upvoted it. I don't realize. Maybe there is no relationship between them. Okay. So I want to figure out if this is true or not.
So whenever the model was overfitting, like the concept that we actually follow is like whenever the model was overfitting, I increase the penalty so that the overfitting of the model will go down.
Yes.
Okay.
Overfitting means that you learn from more samples, right? You give more importance to more samples. Okay. That's what overfitting means. So support vector should be more when you are overfitting. Okay.
So on that time, I'm supposed to reduce my C so that the support vector will be low, so that the overfitting will be avoided. This is the concept, right? I'm not contradicting it.
Correct.
Okay.
Correct.
Done.
So see, I'm not trying to justify based on what is happening. I'm trying to kind of correlate my understanding to why it is happening the other way around. Okay. And I'll try to figure out a way to this. Okay. So this is how SVM is implemented. Okay. I mean, just plot these values accordingly, update the thetas and plot the correct values. You'll be able to see this. Okay. So I'll try to figure out the reason for this. Okay. Why is it that if you increase C, less number of support vectors are there? Sorry, if you increase C, yes. Because if you, it's the other way around, right? If I reduce C, more support vectors come.
Okay.
Okay. So I will try to figure out the reason for this contrapositive thing.
Okay.
Okay. Anyways, any other questions about this? Please ask.
No.
I mean, we have to look at the derivation of SVMs to kind of gain more insights about why this is happening. Since I haven't covered the derivation, I mean, I don't really want to cover the derivation. The reason for that is it is very, very intricate. So for every point, there is a lemma. Like if I'm going to say, this is how you derive it. So there are many, many steps, and each step has a property associated with it. So if I don't describe that property and I don't show you the proof for it, it becomes just bigger and bigger.
Okay.
Okay.
I mean, lost somewhere.
So it will become difficult for you to digest, since I don't think you guys have a background in optimization theory. So every time there will be a question which would be raised. Okay. And I will not have the time to cover like each point in detail. So if you can take my word for it, okay, this is a lemma. So this is something like this. You guys know Pythagoras theorem, right?
Yes.
Okay. If I ask you the proof for it, do you know of it? Does anyone know the proof for Pythagoras theorem? No, right?
No.
No, but then you can ask me, sir, why is it true? And what should I say? No, I can prove it, by the way. I can prove it. But it will take me another half an hour to prove this. So those are the kind of things I want to avoid. And that particular derivation has a lot of properties. Okay, has a lot of them, not just one. It has probably around 30 to 40 properties. Okay, so that's why I want to avoid that. And I don't know why they kept SVMs and logistic regression in the same module. There is a reason why probably they would have, because they are kind of very, very similar. But SVM has an entirely different derivation, but the ultimate result comes out to be, it is the L2 version of logistic regression, very, very similar to that. It's actually the L2 version of logistic regression with a different penalty factor. Okay. The final result comes out to be like this. When we'll see the derivation, okay, I'll probably guide you with some steps, okay. So I'll tell you, okay, if you do this, you'll get this. If you do this, you'll get this. Don't ask me in between, why is this happening? Okay, if you ask me, then I'll show you step by step, which will take time. Okay, that's why I want to cover it at the end. Anything else I can help with about this, what we have seen so far? Maybe you can forget about SVMs for now, but I'll try to find the reason for why is this happening, that when you increase C, number of support vectors are decreasing. Or is it true for like all possible data sets, which I don't think it is. Okay.
Okay.
Which I don't think it has. Okay. It may be kind of, it will probably fluctuate for different data sets. And I saw that as well. So in some cases, the general trend is not followed. So when I tried increasing C, decreasing C, in one case I got 108, and even if I lowered C, I got probably say 106, something like that. So it decreased slightly. So it was not following the general trend.
Yes.
Okay.
Like now also we've seen, right? Like if it is we were kept around 1000, it gone down suddenly to 109 now.
But no, it is gone down. It is going down, right? So that is good. But if you make it, let's say, a little higher, it will probably be 110. Okay, if I make it a little higher, it would probably become 110. Okay, hopefully, I don't know. I saw this in a couple of values. Okay, see, it became 110.
110. Okay.
So this should go down, right? As per the definition. So
Okay.
I want to figure out if this is really true or not, or is this like a generic trend?
Okay.
Okay. So if this is not true for, or is this just true for this data set? I cannot just rely on this claim, because I kind of like prove this with you. If I increase the support vectors increase by 1, which should not be the case.
Okay.
Okay. So that's why I said I don't rely on these things. Okay. So this guy is also saying this. Okay. It is saying that I increase C. Look at the values of C. Okay. If it was 1, it was these many support vectors. Okay. Okay. If this is 10, in his case, do you see that it is decreasing actually? I just gave you a counter example where I increased C and my support vectors got increased by 1.
Yes.
So I cannot just rely on this, right? But maybe there is a generic hidden truth in it. I want to figure that out. Okay.
Okay, sir. Yeah.
Or I'll go and explore. Okay, I'll go and explore.
Okay.
All right. We'll meet tomorrow, and then we'll see how to apply binary classifiers to multi-class datasets
Okay. On Wednesday, right?
on Wednesday. Yeah, on Wednesday. Whenever we meet.
And Senator, this is about my computer specification. Actually, I'm thinking of increasing the RAM. Like I think I'm only having 4 GB of RAM.
Don't think of increasing anything. Use Colab.
Okay.
Okay. Rather buy a new laptop in that case, because
Okay.
if the laptop is old, you will not even get a
This-
compatible RAM right now.
Okay.
Even
Okay.
if you go to a computer market, you will not find a RAM with the clock cycles that are matching with your RAM. Do you know that?
Okay.
Like, if you want to add new
Yeah,
RAM,
that the clock speed will be equivalent. Yeah.
no, if it is not equal, then your system might crash. It will always give you blue screen of death.
Yeah.
So don't do that. Okay. If
Okay,
it's
then.
especially if it's an old laptop, it is difficult
Okay.
for you to find that DDR3 with the same clock cycle. If it is DDR2, forget about it. That
Okay.
technology is gone. You will not find it anywhere.
Okay.
And nowadays
Now-
you have DDR4, by the way.
DDR4 and 5, like
Maybe
5, I'm
some,
not
maybe 5 is also there. I
Yeah,
don't know.
I
Okay.
think DDR5 I've seen in some kind of a
Okay.
YouTube video or something. DDR5 was came.
Probably it's there in, let's say, very advanced laptops. Okay, I mean,
Okay.
which cost maybe say 2.5 lakhs or higher. But
Okay.
generic laptops, I only see 3 and 4.
Okay.
Okay, so 4 is the more popular one. 3 is also kind of becoming obsolete. So 2
Okay.
you will not even find.
Because like whenever I'm working on some kind of project and stuff, like I'm installing the MongoDB and everything on my local system, so that connecting to that Colab and that things I'm facing an issue. So that's what I thought of.
It is a problem. So why don't you just make a generic piece of code? If you run it once, let's say it takes 10 minutes. Okay, so put everything in that mount command, your data sets. Okay, that should take 10 minutes. So I mean, just run it, and maybe you drink water, go have a walk, and when you come back, everything would be ready.
Okay.
And to
Okay,
just make a
Sanatan.
generic function. Okay.
Okay, Sanatan. Yeah.
All right.
Let me do it. Yeah.
So
Thank you
another
then.
one, like not a class related doubt.
Yes.
Actually, I have already raised a query also for this with the Google team.
Yes.
11th August Friday sessions recording is not uploaded.
Oh, okay. So Shilpa,
That's why
I
like there
don't
was a
have those
revision
privileges.
break for that.
Oh, okay. I really don't have the, I mean, credentials, if that's what you're asking me.
Okay.
To, I mean,
11th, right?
no, see, if I had, I would have been the host, right, today. Or somebody came and made me the host, sorry.
Yeah. Yeah, I think Gooey
Someone
people
came in
made-
between, yeah.
Because
So,
these are the additional sessions. I don't know if they are like properly updating it on time or not, the recordings, because
okay.
Yeah.
Okay.
I think
recording
that's
helps
the
a
only
lot
I'm
in the
saying.
revision.
Let's do one thing. Okay. Let's do one thing. Okay. I'll send the text to the team. Okay.
Yeah.
In front of you. Okay. So that you guys are
Okay.
convinced I've done my duty.
No,
I'll do it
Because
right
like
away.
raised
on
a query
7th,
actually
yes,
with the Google
because
team.
on 11th I was also not there in the class. I think I've left behind. So I thought of jumping in and
See, I am
looking
like
at the recording.
intermediator. Okay. I'm kind of, you can say, a freelancer. Okay. Who works for them. So I don't have any say in how they manage their portal. I'm not the one who's managing all that.
For these things, I think better we make
No,
it
no, I'm
go
not.
to the
I don't even
coordinator.
have an account on your Zen portal.
Okay.
Okay. I have no connection to the Zen portal at all. My job is to just deliver and leave. Okay. But since you're asking me, okay, I'm going to send a message to the team saying that, okay, 11th recording is not available. So perhaps they will expedite and upload it there.
Okay.
Okay, just a second. Okay. I'll mention it to
Let's
the
wait for
main
today,
coordinator.
else by the
Yeah, you guys also
evening-
email. Yeah, you guys
Yeah,
also email, right?
Yeah. But Shilpa, like you have your coordinator, right? So I think you can get in touch with them. Like
I've already
whenever
raised a Zen query for that, but there's no
Yeah, but
response.
the query was taking time actually. Like whenever the things or whenever I'm facing any issues, I'm just making a phone call directly to the coordinator. Uh, then the coordinator was doing their job as soon as they can. Because for me, it was worked all the time.
Okay, okay, I'll connect on call then because still now I have used the Zen
August
portal.
11th, right? Huh?
Yeah,
Yes,
yeah.
yes,
August
11th.
11th.
Okay. All right. Okay. So I will mention to her. Okay.
Yeah.
Okay. This is on the Zen portal, right?
Yes, yes,
Yes, in the
yes.
Zen portal.
Okay. All right. So I'll mention it to one more coordinator. 1 second. Her name is Rekha. So, I mean, whosoever does it, okay, they'll do it for you.
Okay.
Oh, thank you, Sanam.
Yeah. Okay. All right. Okay, I'll try to find out the reason for this, and if I believe that there is no connection between them. Okay, as far as I see it from the experiments that we have just done. But if there is a generic trend which is followed, let me try to figure it out. Okay, if that's there or not. Okay.
Okay.
We want to be very sure. Okay, if you appear for an interview, you should not be able to. I mean, you should be able to answer this question. Okay. All right.
Okay, Senator.
All right. See you guys on now Wednesday.
Okay, Senator.
All
And
right. Bye, everyone.
holiday.
Yeah, happy holiday to you as well.
Thank
Take care, everyone. I'll upload this and we'll meet up now on Wednesday. Bye bye.
Yeah. Bye-bye.